Hello and welcome everybody. Hope you are doing great. So today we are going to talk about momentum. It's really interesting topic, and you guys will really enjoy this topic. Let me start with the very important thing that the concept of the seat belts and the airbags used in motor vehicles is usually to protect the drivers and passengers whenever the car and the vehicle get crashed and it is bumped into the trees. So these airbags are like very large balloons. So during a car crash, the airbag inflates and in very short interval of time, and you can see that this cushion provide increase in the time span that reduce the injury and the effect of the hitting force. So first and foremost thing, if we look at the question that a car is colliding with the tree causing airbag in the steering wheel to deploy, what happens to the driver and passenger as the airbag deploys and car suddenly comes to stop? So first and foremost thing we need to remember that when car is going to suddenly stop, the driver and passenger are going to hit the dashboard or the steering wheel, and it can be a huge impact and injury on the both driver and passenger. But when we think the safety provided by the car manufacturer companies, that when suddenly brake is applied or car get hit to the tree, the seat belt is the first thing that stops or reduces the pace of the motion toward the dashboard, and also the airbag pops out of the steering wheel and also from the dashboard in front of the passenger. So this airbag actually reduces the it, acceleration, and time lapses, time increases, due to which the impact of the force reduces. So we can simply say that the rapid inflating of airbag cushions the driver and passenger and slows their forward motion during the collision. Now I'm talking to about this simple scenario. For example, we have a heavy vehicle, yellow truck, and a car. They are approaching to each other, or simply you can say if there is a vehicle that is heavier in the weight and the car is lighter, so, which one will be difficult to stop? Obviously, as we know that the truck is heavier, so it will be difficult to stop. But one thing that we also need to remember, it's not only the weight or the mass of the object that affects the motion. There is some other components like speed is also involved. Like if you say the car is moving with very high speed, so it is also difficult to stop the car as compared to the heavy truck. Or we can also say that if this truck is not moving whereas car is moving, so or truck is moving with very slow speed and car is moving with very high speed, so it will be a different scenario. So to understand this, we need to talk about a very important factor or a physical quantity that we call a momentum. Usually, when we talk about momentum, we need to know that momentum is actually the force that is applied on an object for some time to change its motion. So, in simple word, we can say that momentum is a physical quantity associated with the force and the time interval to change the motion of an object. It is usually denoted by a symbol with P, small alphabet letter P, and it is having a unit kilogram meter per second. So here I would like to talk about one more thing, that this momentum, that we usually use the term momentum with the P, has another mathematical way of explanation. So we can say that the momentum is also a physical quantity. I know that I define that momentum is associated with force and time. So there is another definition that we need to remember, that momentum is also calculated when you multiply mass of an object with the speed. Product of mass and the velocity is better word to write. So we can also say that it is the mass and velocity. Mathematically, I told you momentum is denoted by letter P, and mass with letter M, and velocity with letter V. So we can say momentum is denoted by P is equal to M times V, as we can see here, P is equal to mv. So I would like to talk about this in this way, that whenever we are going to calculate momentum, so you can use this triangle, that momentum is equal to m times v. This line is showing division, this line is showing momentum. So similarly, we can also say that m is equal to momentum divided by v, or v is equal to momentum divided by m. Here I am going to talk about the unit of mass is kilogram, and unit of velocity is meter per second. So we can simply say the SI unit of momentum is kilogram meter per second, and this unit of momentum is simultaneous or equivalent to another unit, that is Newton times second. It is, you can say, N stands for Newton, that is unit of force, times second. As I told you in my previous slide, that momentum is related to the amount of force needed to change the object's motion in a given amount of time. So here you can see this is amount of time and this is amount of force, and unit of the force is Newton, unit of the time is second. So that's why you can also say momentum is equal to force into time, or you can simply say that its unit is Newton second. Okay, there is one more thing. If you focus that I use the word velocity, and velocity is a vector quantity, mass is a scalar quantity, so we can simply say that momentum is also a vector quantity, as it is having also a vector quantity, so it is directional quantity. When something is directional, it may be a positive or negative. So if velocity is going to the right, we consider it positive. So momentum will also be in the same direction, to the right positive and to the left negative. So we can say that momentum can be either positive or can be negative. So we can simply stand out for the momentum that this is the positive and this can be negative. But if you say it's a vector, so what is its direction? So you have to mention it is along the velocity direction. So wherever the velocity direction is, momentum is also in the same direction. Now, if you look at this diagram, in this diagram, there is a very important phenomena, that a heavy truck is moving with 3,000 kilogram, and the heavy truck with a mass of 3,000 kilogram moving with 10 meter per second, whereas car is 1,500 kilogram moving with 20 meter per second. So to compare their momentum, what is the relationship? So we can simply say, as momentum is related to mass time velocity, so momentum of the truck is mass 3000 times velocity is 10 meter per second. So you can simply say the momentum of the truck will be equal to 30,000 kilogram meter per second, or you can say 30,000 Newton second. On the other hand, when we try to talk about momentum of the car, so momentum of the car is also 1500 kilogram times 20 meter per second. So we can say this is also 30,000 kilogram meter per second. That is also similar to the momentum of the truck. Now in this question they are asking that which one is uh, had which one would be harder to stop. So I'm telling you the truth, because both have the same momentum, so both will have the same amount of momentum, and both are comparatively having same amount of hardness. They will be stopped. So as difficult it is to stop the truck, the same amount of difficulty you will feel the stopping the car. So it's the same amount of stopping both. There is one very very important thing that I would like to talk about, that if I said in the previous slide that momentum of the truck is equal to momentum of the car, so if we want to keep the momentum same, you can say mass of the truck is actually twice the mass of the car. So similarly, the velocity of the truck will be half of the velocity of the car. So in this way, if you can see, velocity of the truck to the right is 10, so car's velocity is 20, because it was half the mass. So as you can simply say that if you double the mass, uh, momentum will be doubled. If you half the mass, momentum will be half. If you double the velocity, momentum will be doubled. If you half the velocity, momentum will be half. This is a simple scenario. But if you need to keep the momentum same, you want the momentum same, so you have to remember one of these quantities will be a decrease, other will be increased. If you have the mass, to keep the momentum same, velocity will be doubled, or vice versa. If you double the velocity, mass will be automatically half. I can just give you a simple scenario. If I want momentum, like in this truck is 30,000 newton second, so if mass was 3000, automatically velocity was 10. But if I said mass goes to half, velocity goes to double. So velocity increases, mass decreases. Here we just have to remember one thing. If you are talking about direct proportion of mass and velocity are directly related to momentum, but if you keep the momentum same, then you must have to remember that smaller mass will have greater velocity and greater mass will have smaller velocity. I also talk about the momentum is a vector quantity. So if momentum is a vector quantity, it is dependent on the direction as well. So if you are talking about there is a ball that is moving with velocity v1 and mass is m1, and you change its velocity from v1 to v2, so there will be a change in momentum. So to find change in momentum, it is usually denoted by delta p, sorry. It will be m delta v, and when you talk about m delta v, it will be v2 minus v1, or you can say mv2 minus mv1. So here if you have two components or the vectors of the momentum, so how we can use to find the change. So if you have to find mv2 minus mv1, so head to tail rule or tail tip method says that mv2 will be added to negative of mv1. So first thing first, I will talk about mv 2 plus mv2 as it is, as it was. So I can just say it's the same mv2, and negative of mv1 when I am saying, so it will be the same vector but it would be opposite. and when I will draw it here, so it will join the head of the first vector with the tail of the second vector. This will be mv1 same amount. So result will be from head of the last vector to the tail of the first vector. For example, this is the dashed line is head of the last vector to the tail. That shows me m delta v, or you can also say delta p. So this is the result of the change. So how much the momentum change, the dotted line is showing there. Here let us solve the problem to understand the momentum same. For example, we have a pickup and mass of the pickup is given 2250 kilogram, and its velocity that is toward the east is 25 meter per second. We are asked to find momentum, and from our triangle of the momentum we know that P is equal to m times v. So P is equal to m, 2250 kilogram, times velocity is 25.0 meter per second. When we multiply both of these, what we get is we got the result, and the result, let me check, is it will be, let me have a calculator please. So I'm going to calculate it. It is 2250 times 25.0. So I got is 56,250. So I can just simply say 56,250 kilogram meter per second. Okay, here one very very important thing, that if you look at the question, 2250 has three significant figure. Similarly, 25.0 has three significant figure. To convert my answer into three significant figure, I will move it to 563,000 kilogram meter per second, or I can simply say 5.63 uh, into 10 to the power 3 kilogram meter per second. Both of these answers are considered as correct, but we don't need to forget that the direction was to the east, so you will mention it as to the east. Without direction, momentum is useless. Similarly, we have a deer here that is having a mass of this one, head on toward the truck. Head on can be both are moving toward each other, or can be one is slow, one is faster, so they can be uh, hitting from the backside. So deer with a mass of 146 kilogram is running head on toward the truck. So deer is going toward the truck. So it means the truck is facing north, so deer is facing to the south. So you have to remember the direction of the deer is south. So what I would like to say, that the momentum of the deer, P is equal to m times v. P is equal to 146 kilogram times v is 17.0 meter per second. So what can we do? 146 times 17 is equal to 2482 kilogram meter per second, and this one kilogram meter per second, because the deer was heading toward the south, so this is toward the south. So we can say that the deer was moving toward the south, so it will be toward the south. But here you have to see, we have three significant figures. So again, 2482 is rounded to 2480. One more question that I would like to do. We have to find the velocity in this part. When we are going to find the velocity, our concern is velocity, and for velocity, if you see, momentum p is equal to m times v, so v is equal to momentum over mass. So we can simply say that momentum of the pickup truck from the sample problem. The momentum of the pickup truck here, what was the momentum? It was 56,300, and if you want to be exact, 56,250. So 56,250 is the momentum, kilogram meter per second, over mass is 1210 kilogram. So velocity will be 56,250 divided by 1210. So I got is 46.4876. 46.4876 meter per second. Now here we have three significant figures again, so I would prefer to write 46 point. This all will be round off, so 8 is more than 5, so I will add it to it. 46.5 meter per second. As pickup moving to the east, it means the velocity is also to the east. Okay, here I would like to one more very important thing. If you are asked to find the mass, so sometime you will use the same. For example, you have given a velocity of 46.5 meter per second, and you are asked to find the mass, but momentum is 56,250 kilogram. If you are going to find mass, so what you will do, you will do mass, as you can see here is momentum over v. So you can just simply say the value of momentum, 56,250 over 46.5. So this will be rounded to 1210 kilogram of the mass. So you can just simply, and mass is a scalar quantity. We usually don't need to talk about the direction for this one. So guys, this is all about our lesson about the quantifying momentum, and in this lesson uh, we just learn about what momentum is and how to calculate the momentum, what are the basic rules to find the momentum, and uh, how we can quantify it. Thank you so much, guys, and bye bye for now.